50 years ago, the refrigeration engineers at HCR set out to find a solution for moving traffic through cooler and freezer doorways that worked better than heavy, slow-moving cold storage doors or even fast-acting electrically heated utility doors. Using a completely fresh engineering approach and the principles of psychometrics, those engineers developed the new technologies that changed the recirculatory air door industry, HCR. Today, with more than 50 years of field experience, HCR has gone from the drawing board to the field, from theory to application, and from a basic idea to reality. It has proven itself with thousands of successful installations worldwide, and with the largest, most demanding and cost-conscious retailers and mass merchandisers, now utilizing sophisticated computer modeling software to improve the science of psychometrics and the art of airflow and metal fabrication. HCR continues to pioneer technology for cold storage applications. According to ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, within seconds after a door is opened, a natural air exchange occurs in a typical two-way air exchange from a cooler to a freezer or a cooler to a non-refrigerated anteroom. Dry, cold air from the cold side forces through the doorway at the bottom, while warmer, moist air from the warm side pours through the doorway at the top. The escaping cold air flows along the floor where it forms fog and chills the floor below dew point, causing condensation to develop, meaning a slippery, wet, or icy floor. Inside the colder room, the invading warmer, moist air rises toward the ceiling where it travels to the coldest part of the room. The freezer evaporators along the way. This warm, moist air precipitates out and builds as frost. Typical accumulation of frost above the door falls to the floor and turns to ice. The frost also accumulates on the ceiling, walls, beams, racks, even on the product being stored. This infiltration and exfiltration air depiction is taken from Chapter 13 of the ASHRAE Refrigeration Handbook. Traditional cold storage methods of stopping the natural air exchange between rooms with different temperatures have mainly been use of fast-acting vertical or horizontal sliding, bifolding, or roll-up hard doors. Rigid doors are tremendously effective when closed, but their effectiveness diminishes as open and closed cycles increase. Rigid doors work well where traffic is low and open and closed cycles are few and have short duration, or when the room temperature differences are not extreme. But there comes a point where a rigid door no longer serves as the most cost-effective solution. The more that door is opened, the more air exchange takes place, and the doorway is subject to all the problems that would occur as if there were no door at all. Cold air escapes, warm air and moisture infiltrate, causing icy conditions on the floor. Frost accumulates on the freezer evaporators and all equipment and products inside the freezer. HCR air doors keep separation between the two rooms, but also allow totally open access. In this way, the open doorway is always closed to prevent costly air exchange, yet always open for absolute accessibility. HCR's Model AC air curtain creates a virtual curtain of air that repels a naturally occurring air infiltration. This model is used mainly in high-traffic, non-frosting conditions. When temperature or humidity differences increase, the Model CAC or conditioned air curtain can be used, which adds heat when needed to condition the air. With Model DCAV, or double conditioned air vestibule, the door induces airflow patterns like the single air curtain. When two are placed together into to work in harmony, it creates an air vestibule between the two air streams where the air is captured and treated to a non-frost, non-fog state. This model creates a vestibule with no visible doors. The 3CAV, or triple conditioned air vestibule, creates an additional vestibule to condition the air. It is used mainly between rooms with extreme temperature differences and very high traffic. The frost elimination process is similar to the Model DCAV, but an additional air curtain is added to improve efficiency as well as increase a model's temperature range applicability. Traffic doors can be added to all HCR models for even greater efficiency in the conditioning process. The HCR model PCAV is a conditioned air vestibule, measuring 12 inches in the direction of travel that dramatically reduces moisture infiltration into walk-in freezers while reducing temperature loss when the door is left open. This double-strip conditioned air vestibule also eliminates ice problems, resulting in less evaporator maintenance, including damaged fans and motors, and general ice cleanup, all providing a quick return on investment. Model PCAV is constructed of either 18-gauge stainless steel for pedestrian pushcarts and pallet jacks, or powder-coated 3/16-inch thick steel for forklift traffic. This model does not require bollard protection, as it was designed with forklifts in mind. Model PCAV requires the least floor space and wall space of any HCR model. Every HCR unit is custom engineered for the specific conditions at your site. Using 3D modeling allows HCR to produce equipment with unmatched precision and quality, each design fitting the specific space constraints at your doorway and with a swift installation in mind. On especially complex applications or for new offerings to the market, Computational Fluid Dynamics software, or CFD, allows HCR to evaluate the natural airflow through the doorway compared to the block of the HCR air curtain. This computer model of the air curtain is used to show how the air is efficiently blocked, mixed, and treated to a non-frost, non-fog producing level, allowing HCR air curtains to achieve the frost elimination they're famous for. In more extreme conditions, a second air curtain may be added to increase the efficiency and reduce the heat load to the freezer even further. HCR's breakthrough technology was further documented after Creative Thermal Solutions, a leading test lab for products in the HVAC and refrigeration industries, completed their definitive study of the HCR single air curtain, or Model AC. CTS Labs extensively tested the thermal performance of the HCR single air curtain and determined that the HCR Model AC is up to 80% energy efficient when stopping air infiltration and energy transfer between rooms with different temperatures. That energy efficiency, when applied to single, double, or triple air door models, or combining with traditional doorway solutions such as hard doors or high-speed fabric doors, allows HCR the ability to provide a complete doorway solution for nearly any application. See how the CTS imaging software takes the actual data and shows the warm and cold air masses being effectively separated, demonstrating the HCR air block when the HCR single air curtain is turned on. The benefits of HCR air doors are visibly dramatic through the elimination of frost and ice, and additionally remarkable in increasing productivity. When applied to large freezers with high traffic or problematic open doorways, fully operational HCR units are essentially the same as adding refrigeration capacity. Merchandise movement is significantly increased, and HCR units help extend critical space utilization. Safety concerns are reduced due to the open space and elimination of moving door parts. HCR makes the appeal of an unencumbered wide open doorway for your workers to move about freely and efficiently. HCR, a revolution in the recirculatory air door industry. Find out more at jamisondoor.com.